So in this video today we're going to be approximating and computing the area using Riemann sums, and to be more specific we're going to be using the left endpoints for Riemann sums. And what the left endpoints for Riemann sums is L of n is equal to delta x times n minus 1 times the summation n minus 1, j is equal to 0, of f of a plus j times delta x. Delta x. And an example we're going to be doing today is f of x is equal to x minus 1 on the interval 1 to 2, and then we want to know what is L of 5. So what this L of 5 means right here is it means we're going to split the interval 1 to 2 into 5 different rectangles, so it's going to be like that. And as you can see, it's not that. We have some overlapping area, some area that's unnecessary. That's just extra area, and that is one reason why Riemann sums isn't that good to compute or approximate area, but it's something that you really have to go over though in calculus. So this is the function f of x, which is equal to x minus 1. So this is the graph x minus 1 on the interval 1 to 2. And we're going to be computing the area of all of these triangles. So we're going to be computing the area of each triangle and then adding all the triangles up together. Now just remember, this is an approximation, so it's not exact area. So now let's just go ahead and start. So we can rewrite f of x equal to 1 over x. Now we're going to write L of 5 is equal to delta x times the summation 5 minus 1, j is equal to 0. F of a, 1 is a, plus j times delta x. So now we're going to figure out what delta x is. So what delta x is it's b minus a all over n. So what that's going to give us is 2 minus 1 all over 5, which equals 1 over 5. So now we could say L of 5 is equal to 1 over 5 times the summation 4, j is equal to 0, f of 1 plus j times 1 over 5. So what we're going to do is we're just going to leave this j alone for a while. That's going to give us our endpoints on the graph, so we're just going to leave it alone until the end, and I'll explain what we do after that. So we're just going to rewrite this as summation j is equal to 0, f of 5 over 5. Let's erase that, rewrite it, plus j over 5. We're going to write L of 5 is equal to 1 over 5 times the summation 4, j is equal to 0, f of 5 plus j all over 5. So now we're right here. So it's very important to keep the summation notation here until you finally start adding all the rectangles up, and that's where the j comes in. So we're going to start off with j is equal to 0. Then we're going to go all the way up. That's what this 4 means. That's kind of like our limit. So we're going to go all the way up to 4 like that. So now what we're going to do is we're just going to add the sums of all the triangles now. We're going to plug in the numbers for j and add each one. This marker's going out. So it's L of 5 is equal to, these markers are going out. L of 5 is equal to 1/5 times 5 plus 0 over 5 plus 5 plus 1 over 5 plus 5 plus 2 over 5 plus 5 plus 3 over 5. And we're just going to go 5 plus 4 over 5. So now, we're just going to write it out again. L of 5 is equal to 1/5 times 5 over 5 plus 6 over 5 plus 7 over 5 plus 8 over 5 plus 9 over 5. These markers are really going out. So now if we just add all those up, we're going to get L of 5 is equal to 1/5 times 3.7281. And then if we multiply those two together, L of 5 is equal to 0.7456. And that is your final answer. So the area under the graph is going to equal the area between the graph and the x-axis is equal to 0.7456. So if we redraw that, looks like that. So 1 to 2. So what we did is we split it up into 5 different triangles. So 1, 2, 3, 4, 5. We took the area of each triangle and added them all up. And that's where we got 0.7456. Was by calculating the area for each triangle and adding up all the area, and we got 0.7456. Now you gotta remember, this is just an approximation. And remember what I said at the beginning of the video, is this is not a really good way at all for calculating area between a graph and the x-axis, because if you can see, there's little overlaps for each triangle. So we got more extra area, so this is probably too much. It's probably not the exact, which is it's not the exact at all. But we got overlap, so it's not the exact, it's just a rough approximation. So Riemann sums aren't used that much at all. We usually rather use stuff like the fundamental theorem of calculus pretty much, because it's a lot more, it's accurate and precise, and a lot easier than taking the summation of all these triangles between the graph and the x-axis. So that was your example.